Find the second derivative of x equals t cubed minus t, y equals t squared. In an early example, we saw that this is the graph of these parametric equations. The second derivative d squared y over dx squared is x prime of t times y double prime of t minus y prime of t times x double prime of t over x prime of t cubed, where x of t is t cubed minus t, so x prime of t is 3t squared minus 1, x double prime of t is 6t, y of t is t squared, y prime of t is 2t, and y double prime of t is 2. Thus, the second derivative d squared y over dx squared is 3t squared minus 1 times 2 minus 2t times 6t over 3t squared minus 1 cubed. Multiply this out to simplify. We have 6t squared minus 2 minus 12t squared over 3t squared minus 1 cubed, or minus 6t squared minus 2 over 3t squared minus 1 cubed. Factor out the negative 2 in the numerator. We have 3t squared plus 1 over 3t squared minus 1 cubed. Notice that 3t squared plus 1 is always positive times negative 2, so the numerator is always negative. The denominator is negative only when 3t squared minus 1 is negative, or when t squared is less than 1/3. This is only true for t value between negative the square root of 1/3 to positive the square root of 1/3. So the denominator is negative for t values between negative square root of 1/3 to positive square root of 1/3. Since the denominator is negative for these values and the numerator is always negative, the second derivative is positive for t between negative square root of 1/3 to positive square root of 1/3. This can be seen on the graph. From t equals negative the square root of 1/3 to positive square root of 1/3, the graph concaves up. For t goes from negative infinity to negative square root of 1/3, the graph is concave down because the second derivative is negative. And the second derivative is again negative from the square root of 1/3 to positive infinity, indicating that the graph concaves down. For increasing and decreasing, we would look at the first derivative. Notice that this first derivative is 0 when t equals 0, when the denominator is not 0, but the numerator is 0. And so when t equals 0, we have a horizontal tangent line. For t less than 0, the first derivative is negative, indicating that the curve is decreasing. For positive t, the curve is increasing because the first derivative is positive.